So moving on, we've looked at univariate statistics. Right? We've looked at running frequencies on the categories, the answer choices for a categorical variable, or an ordinal variable, actually, in a lot of those cases. But you don't really get into analysis, really, until you start looking at relationships between variables and later on among, more than two variables. When you're looking at categorical data, the way that we generally analyze those relationships is through something known as crosstabs. And in other words, you're taking one variable and you're looking at the values of another variable by the categories of the first variable. The output from crosstabing two variables is often referred to as a contingency table, because you're looking at the values of the second variable contingent on the values of the first, if that makes sense. When I say categorical, thinking back to our different levels of measurement, we had nominal, ordinal, interval, and ratio. Both nominal and ordinal fall under the umbrella term of categorical because both of them are variables where the values represent categories. With ordinal data, they're ordered categories, but they're still categories. Now, when we looked at frequencies, those are statistics in the sense that we are looking at a sample. We're looking at the results of a sample and trying to get a sense of what's going on in the population. But we haven't really done any kind of statistical testing. When we look at crosstabs, there are a few specific statistical tests that we will typically look at to determine whether the relationship between the two variables is first, what we would call statistically significant, which doesn't always mean what people think it means. But if you remember back to our discussion on statistics, statistically significant really is about the representativeness of the sample. How confident are we that the relationship that we're seeing in the sample actually exists in the population? Right. So with crosstabs, the statistics that we'll look at are the chi-square statistic, and then there are two related statistics, phi and Cramer's V. And in some situations you will use phi, and in others you'll use Cramer's V. And we will discuss what those two what those situations are. Now, as we've discussed in the past, 5-point scales, like the ones that we've used here to measure musical preferences, they're generally treated by marketing researchers as interval level, and that's so that we can run certain mathematical procedures on them. That some of them that we'll see later on in the course, like comparing means and doing correlations. But they are, technically speaking, ordinal. And in any case, there are categories, so we can use them in categorical data analysis. And really, any interval level data can always be kind of collapsed into categories anyway, even if you're looking at number of times that you've gone to the park in the last 2 years. You could always collapse that actual number into, less than 5, 6 to 10, 11 to 15, right? So this type of analysis can be used for analyzing numeric data if you were to collapse it into categories later on. So I'm back in our SPSS data file, and I still have it filtered. If you look over here, I have it filtered still for the 1990 data from doing the homework problem before. And so the question that we're presented with is to look at the relationship between race and country music. So we looked at the country music variable in the previous module. So you have some idea what that looks like. And the race variable, if you recall, and we can look at it here, is presented with 3 valid categories: white, black, and other. So let's just get right to the heart of it. If I want to run a crosstab, I go to Analyze, Descriptive Statistics, Crosstabs. And again, keeping in mind, I'm already filtering the data for the 1993 year, the wave of data from 1993. Now, some of the things I'm going to tell you to do here are conventions. That it's not that you have to do it this way, or that it would be wrong to do it some other way, but this is the way that I've generally done it. And I find that in having kind of like a set way of doing this, I remove some of the potential indecisiveness in the process, and it just makes it a cleaner more efficient process. So if you think back to charters, with charters, we tried to frame all of our research questions in the form of, what is the effect of X on Y, right? So you have an independent and dependent variable. And the reality is not every marketing research question that you'll ask will fall very neatly into those categories. Sometimes you're just looking at the relationship between two variables, and it's not that one necessarily is being posited as the cause of the other. It's just like, hey, I want to see, like, do people who like football like lacrosse? I'm not saying that liking football causes you to like lacrosse, but is there an affinity? Like, so you get a lot of questions like that. Two brands, and do people like these two brands? And maybe there's something else that's driving that. But to the extent that you can, I think it's helpful if you can define one variable as sort of your predictor and the other one as your effect, your cause and your effect. So in this case, we're looking at race and country music preference. It's unlikely that someone's feelings for country music will cause their race, right? But it's plausible, at least, that someone's racial background may have some cultural, impact on their preferences for music. So I'm going to approach this as if I'm asking the question, what is the effect of race on preference for country music? And whenever we can set it up that way, by convention, we would put the independent variable, in this case race, in the column, and we would put the dependent variable, in this case preference for country music, in the row. Again, that's just sort of like my shorthand. It helps me keep things straight. You can analyze this relationship by putting race in the row and country in the column. It would work. But in trying to make things as simple as possible, I would encourage you to follow this convention. Column would be the independent variable, dependent variable in the rows. Now, we've got a few other options that we have to look at here. Some of them we won't need for our initial exploration, but I'm going to have you put them in now anyway so that they're available when we move on to the next stage. The first thing I want you to click on is cells. And if you click on cells, you'll see that the only thing that's checked off by default is observed. Now, observed, those are your actual counts. That's going to show you how many white respondents liked country music very much, how many black respondents liked it but not very much, etc. You get all the different cells, and it'll tell you within this sample how many were there. Expected is something that can be useful, and if you remember your chi-square test from your stats class, I mean, the whole calculation of the chi-square statistic is based on differences between observed and expected. But SPSS actually makes this really easy for you, so I'm not going to go in depth in that because I want to keep this as simple as possible. As I've said in previous videos, I'm trying to take kind of a very functional perspective here. I want you to be able to do this, and I'll give you more information as you need it, but I want you to feel comfortable executing these basic tests, and then as we get into the more complicated stuff, we'll add on the additional information you need. So anyway, observed counts are checked off by default. The other one that I would recommend that you include are the column percentages. And specifically when you are putting your independent variable in the column and your dependent variable in the row. In that situation, it makes sense to look at the column percentages. The rest of it, you can just leave. I'll click continue. And the next thing I want you to look at is there's a button here, statistics. If you click on statistics, it will bring up this menu. And there are two things. So just making this as straightforward as possible. There are two things I want you to check off. There's the chi-square box, which will produce the chi-square statistic. And then under nominal, there is phi and Cramer's V. There are other measures here that may become relevant to you at some point in the future. For our purposes right now, those are the only two that we need. So we'll check those off, and they're now included, or they will be included in our output. At this point, we can click paste. And if we look at our syntax, you'll see we have added this syntax. Now, clicking on the cells button and putting that in, that added this line. Clicking on statistics and adding in chi-square and phi, that put in that line. If you didn't do those, basically you'd get the same thing, but just without those two lines. It wouldn't have put anything in there. Okay, let's highlight that, and then we will run the selection. And you should get this output. We have 1,574 valid cases. There are 32 missing. Now, when you do a crosstab, unlike the frequency table, it's not going to create another category over here for missing. It's going to base the crosstab on the valid cases only. So anything missing just falls out. And if it's missing on either variable, it falls out. It's what we call list-wise deletion of missing data, and that's something we'll talk about a little bit more later on. But the basic idea is any case, right, any respondent who's missing data on either variable, just drop them. We can't use them because you need to have values on both. Okay, what do we see here? The first thing, anytime you do any kind of analysis like this, the narrative is the most important thing. Can you tell some sort of story? If there's no story here, no one will care what the numbers are. If you show them, this is statistically significant, but the difference that you're looking at doesn't have any substantive meaning. And that happens more frequently than you might expect, especially when you're dealing with very large data sets. When you're dealing with data sets with 100,000 cases, like everything is statistically significant, but not everything statistically significant is worth talking about. And we'll get into statistical significance in some more detail down the road as well. But I think that many students, and not just students, I mean, people out in the work world, right? They misconstrue statistical significance as sort of like highlighting for what's important. And I think it's fair to treat the absence of statistical significance as disqualifying criteria, because the whole idea there then is you don't even know if what you're looking at is real. But if something is statistically significant, that's just table stakes, right? Now you can look at it and you have to evaluate whether it's meaningful. But being statistically significant in and of itself doesn't mean, hey, look at me. You should look at me. It doesn't. And a lot of researchers and analysts seem to treat it that way, almost subconsciously. But anyway, getting back to this finding specifically, what are we seeing here? What is the story? Well, we can see that 27.3% of white respondents, and so this is a column percentage, so it's 364 divided by the column total, 1,332, 27.3% of white respondents like country music very much, compared to only 4.8% of black respondents and 17.1% of other. So whatever other racial category, if you don't consider yourself white or black, you fall into other. So that's 8 out of 166 black respondents. If we look at the like it category, the numbers are actually pretty similar in terms of percentages. 37.5% of white, 37.3% black, 39.5% of other. And this is where it would be useful to have your top two box score, right? But you can see here it's well over half at this point. It's almost 2/3 of white respondents at least like country music, whereas it's less than half of black respondents who do. And then if we look at the other end, your bottom box and bottom two box, you can see now there's not a lot of hate going on for country music here. All the percentages are relatively small, but 7.2% of black respondents versus 3.9% of white respondents, it's not quite twice as likely, but it's definitely more likely, at least in our sample, that black respondents would dislike country music very much. And then when you go into the bottom two box, you're looking at 27.1% of black respondents compared to like 13.1% of white respondents. So it is twice as likely when you look at the bottom two box. Black respondents twice as likely to dislike country music. So I would say that's the story, right? When we're just looking at the numbers, we haven't done any statistical testing yet. We're just reading the numbers. There seems to clearly be a story here. Hey, white respondents like country music more than black respondents. And the other group basically is in the middle. Okay. Now, statistically, what does this mean? Like if we're talking about, do we feel confident that these results are reflective of what's actually in the population, or is it just some random thing in this particular data file. This is what the chi-square test tells you. And so you'll see here, Pearson chi-square with an asymptotic significance, two-sided, of 0.000. Now, two-sided, two-tailed, one-tailed, we'll talk about that a lot more in the next module when we look at comparing means. Everything with categorical data, or at least with nominal data, it's always two-sided because there's no direction, right? The categories don't have direction. Now, these have direction here, but we're treating it as categorical data. So the main thing to take away from it, chi-square, it's always two-tailed, two-sided. And the decision criteria here with this number, this 0.000, is if that value is 0.05 or below, then we would conclude that the difference that we are observing is statistically significant. That is, we are at least 95% confident that the difference that we are observing exists in the population. So this number is sort of like the opposite or the complement to confidence. If it's 0.000, then you're 99.9+% sure that that difference exists. If it's above 0.05, then you fail to cross over that 95% confidence threshold. And so that's the main thing to remember here with this number, is that this represents, if it's 0.05 or below, that it's statistically significant. Now, there's a problem here, though. You'll see there's a note that SPSS produces for us. It tells us that one cell has an expected count less than 5. And if you look up here, you'll see there's one cell here, other and dislike very much, only had 2. Now, that was the observed count, not the expected count. The expected count would be, if you wanted to calculate it, it would be the overall percentage, 4.2%, times the quantity in that column, 76. So 4.2% times 76 would actually give you a value of 3.19. It's not that I do the math in my head. I just know because I've seen this enough times already. But so it has an expected count, and actually it tells you right here as well, 3.19. That's below 5. The problem with that is it invalidates this number because it violates one of the assumptions that you're supposed to meet before you can calculate this. And it also invalidates the numbers down here. So there is something that we need to do to address that, and we will do that in the next video. But before we do that, let's pretend that wasn't there, and let's just interpret, this is statistically significant, and then we get these measures down here, phi and Cramer's V. I want to cover that real quick before I move on to how do we fix this problem. Now, I have to go back to the PowerPoint deck briefly. We had a chi-square test, and it told us that the pattern that we're seeing in the data, the relationship between those two variables, is very likely to exist in the population. We are more than 95% confident in that result. But it really doesn't tell us anything about the strength of the relationship. What we know about the strength of the relationship would be from observing that pattern. Like I said, black respondents were twice as likely as white respondents to dislike country music. But that's not like a metric, right? That's just me interpreting as I'm looking at it and building the narrative. SPSS does produce statistics that can summarize what is the strength of that relationship. The chi-square statistic does not. That's just not what it does. The statistics that do that are phi and Cramer's V. And so in terms of how do you interpret those numbers, they're interpreted the same way. So if you have a value of 0.25 or higher, that would be considered a very strong relationship. If you have a value of 0.15 to 0.25, that would be strong. 0.11 to 0.15 moderate. 0.06 to 0.1 weak. And anything below, like 0.05 or below, we would consider that like there's no relationship. And again, it's the same interpretation guidelines for both phi and Cramer's V. But here's the key. When do you use phi and when do you use Cramer's V? Anytime you have a 2x2 table, in other words, each of your variables has 2 categories, then you would use phi. Anything else is Cramer's V. And so that sounds like, oh, you must use Cramer's V a lot more because it's Cramer's V for everything. But the reality is a lot of these crosstabs that we do are 2x2 tables. Anything where you've got dummy variables, right? characteristic there versus not. Anything yes, no. Male, female. But certainly, like, do you use the brand or not? Those are all binary variables, and if you put them in a crosstab, it's 2 by 2. And if that's the table that you have, you would use phi. Everything else is Cramer's V. It's that simple. And a lot of the time, they'll have the same value, but certainly not all of the time. And in this case, I've reproduced here that same output that we saw here, but here on the PowerPoint slide, we have a phi value of 0.195 and a Cramer's V value of 0.138. Well, the table that we were looking at, remember you had 5 rows for like it, very much like it, etc. And we had 3 columns for white, black, and other. This is a 5 by 3 table, therefore we would use Cramer's V. Well, with a Cramer's V value of 0.138, this would be considered a moderate relationship. If we had incorrectly used phi, we would have concluded it was a strong relationship, when in fact it's really only a moderate relationship. So there would be an implication, or you'd have the wrong interpretation if you use the wrong statistic. In this case, it would be Cramer's V, and it would be a moderate relationship. Now, the significance levels for these tests will always be the same. And actually, the significance of phi and Cramer's V is the same as the significance of the chi-square test. They're all a function of the same underlying numbers. But as I said before, we had an issue, and that issue was that we had one cell that had an expected count less than 5. So this Cramer's V value, we can't really run with it yet until we fix that problem. And the same thing with the chi-square significance value. So in the next video, I'll show you how to fix that problem. But still, whatever numbers you get, this is how you interpret it. If you have 2 by 2, it's phi. If you have anything else, it's Cramer's V. So in the next video, we will continue on, and I will show you how to fix the problem of cell counts less than 5.